Hello. I'm actually doing this in front of a class, so if you hear students talk, that's what's going to be going on here. But we are doing a review over the 410 and 411 sections in your book. So hang on a second. We're going to share the screen. I'm going to close some stuff down. And then it's time. If I have to kill a student because he's talking, I want you guys all to know it's fine that I'm doing that. He's been told that he'll die if he talks too much, and it means he's ready to meet his maker. Okay, so here's what we're going to do. You're not going to see my face because doing this here, you can kind of see the edge of it, I guess. All right, so we're going to talk about the log properties to expand and contract the expressions. This is a class of Algebra 1 students in front of me, so they're not going to know exactly what's happening. But guys, if you want to learn about logarithms, here's what we got. Okay, so there's three basic rules that you have. You're going to start off, if I take any log, and I've got two things that are being multiplied together, you can expand that into two separate logs. Log with the m plus log with the n. It's kind of like when we were doing this stuff with the exponents, where multiplication means I add exponents. It's the same idea with this. Multiplying here means that I'm going to be adding the terms. Silence! Next. If I do that same sort of log, but I'm doing it with a fraction, it's like division. Fraction becomes subtraction. So when we look at something like this, this is going to be log base b m minus log base b of n. So that's going to give us the place that we can fill that in. Left-hand side being the condensed version, the right-hand side being the expanded, because we have more than one thing. And for the last rule, the rule that you use the most often is one that we're going to be doing to involve what you do with a logarithm if you have an exponent. And if we have an exponent for something like this, we basically take that exponent and bring it down to the front as a multiplier, like this. So these are the three kind of rules that we're going to be looking at, what we're going to be using to be able to solve these problems. Now, for the first two, we're either going to be expanding, so we go from something that's one size to two, or we're condensing, which means I take many and put them together as one thing. So first one, the expanding, is actually not bad. If I look first thing that you want to look at is whether you're multiplying or dividing. Because we're multiplying, the first thing that I'm going to do is change this to a plus to separate it out. It's a log base 3, so I'm going to write that for both things. Log base 3, log base 3. And then these are the two terms that I'm going to have right here. Bless you. So now I've got them separated, so they're both their individual logs, but I still have exponents here. Can't have those. You got exponents, then you've got to use the last rule here to bring those down to the front to continue to expand what we're going to be doing. So this is going to be 2 log base 3 of m plus 9 log base 3 of n. And that's what the end of that one is. We know we're done because each of these only have one term, m and n, for each of the stuff. Okay, by the same token, what we're going to be doing is instead of going out like that, we're going to be bringing everything back in. So since the last thing that we did was to bring those exponents down, if they're set up in a way with the problem here that I've got something in front, first thing that I want to do is to take any number that is in front of my logarithm, bring it up as an exponent. I'm going in the opposite direction. So all three of those numbers are going to be going up into the front. So that is going to give us log base 3 of m to the 5th power plus log base 3 of n to the 2nd power minus log base 3 of p to the 7th power. So we've got all three of those now where they've got their exponents. So I don't have to worry about doing that anymore. Now I'm just combining them one at a time. So I take that first pair and combine it. Because it's a plus, it's going to turn into multiplication. So I'll put the times. The two things that I have here, m to the 5th, n to the 2nd, are the two things that get multiplied, and that has been combined together as one logarithm. Now I didn't do anything with this last term, so I'm just going to copy it over. Minus log base 3 of p to the 7th. Now, because I have a subtraction, the last thing that I need to do is to turn that into the fraction. What we have on the first half is what goes on top of the fraction. So it's m to the 5th times n to the 2nd. And what we have second here, p to the 7th, that goes on the bottom. We know that we're done because I have a single logarithm with everything combined. And that's what we got. So that is our second answer with what we're going to be doing. Now we start to use the logs a little bit as we're going to be doing this. And so one of the things we talked about is that anytime that I have an exponential equation where I have a variable up in the exponent, and I've got bases that, I mean, they could be 10 or they could be anything at all. The first step that I want to do in something like this, because I want to get the x by itself, is to take the log of both sides of the equation. So the first thing I'm going to do is rewrite this with the log of both sides. And then I'll rewrite all of the rest of this. So this will be 10 to the x. This will be 20,000. Okay. Now the next thing that I want to do in this case, just like what I've been doing before with the expansion stuff, is because I'm wanting to solve for that x, if I bring it down to the front, it allows me to do something and solve for that x. Can't get the x by itself if it's up there, but if it's down in the front, I can absolutely solve for it. This is now going to give me log 10 is there, log 20,000 is on this side. And what we had talked about before is that if I'm solving for x, each of these are just numbers. So if I want to get the x by itself, all I have to do is divide both sides by that log 10, because it's just like, it'd be like dividing by 3 if we did something like that. So we've got that. We're going to be doing that on both sides. This will cancel out. Hello. And you made the right decision not to walk behind the camera. Okay. So then what I'm going to have here for my x value is that I will have log of 20,000 over log of 10. And guys, there's absolutely no way I can do anything other than plug this into a calculator. So just to make sure that you know how to do that, if you turn your calculator on, you've got this stuff. Make sure that you use the log button, the one that's going to be right here up at the top. And it doesn't exactly matter how you type it in. I'm going to write 20,000 here, divided by log of 10, and that'll give me the final answer, which is 4.301. It'd be 0.2, so I'm just going to keep it as a 0 there. So this is what the answer for my x is. Okay, so generally that one is just going to be going through and making sure that you kind of work. For this next one, it's asking you to use a specific formula, change a base formula. And we did that in class, and it's super easy. But just so that you remember it, the formula itself is going to be this. If I have a logarithm with some kind of base, and I'm taking it of something else, where this isn't one that's like a base 10, so we can use our calculator, we can simplify that by taking the log of the answer over the log of the base. This is like the log button on your calculator, which is log base 10. So it's just an easy way for us to do it. This problem is really just asking for you to take what they've given you, put it in this format, and plug it in. So we'll have a log on the top and a log on the bottom. The 2100 is the answer part, so that goes up on the top here. And the base is 7, so that's going to be down there on the bottom. Now when I plug that in the calculator, if I've got the log of 2100 and I divide it by the log of 7, I'm going to get 3.9312. And again, that's just the calculator telling me what the answer or something like that's going to be. Okay, so here, for this last one, it's asking for you to explain why that x in the equation is equal to a number between 7 and 8. So why is it that this right here is equal to something between 7 and 8? There's two ways to do this. I'm going to give you the easy way and the way that I'm expecting everybody to do that, which is essentially to say, if I use the change of base formula here, I'm going to get an answer. If that answer is between 7 and 8, that explains why it is. So the change of base formula for this would be log of 50 on the top and the log of 2 on the bottom. So if I plug that into my calculator, log of 50 divided by log of 2, I'm going to get 7.2288. Because it's a decimal that is larger than a 0 here, this right here is between 7 and 8. Pretty simple. So with that being said, guys, that's the last problem and the last part of the review. So I'm going to stop sharing and I'm going to stop recording. Everybody say, woo!